Hello friends, myself Professor Rajendra Baburao Gharse, Head of Electrical Engineering Department at NB Navle, Sinhagad College of Engineering, Solapur. I am having a teaching experience of 9 years. I have completed BE in Electrical Engineering from Government College of Engineering, Karad, and MTech from Indian Institute of Science, Bangalore. In the achievements, I have secured the All India 7th rank in the GATE examination with a percentile of 99.96. In my last video, we have discussed a simple example based on calculation of y parameters, right? Today we are going to discuss calculation of y parameter for some critical cases or for some critical circuits. Okay, next, so let us discuss. Yes, suppose our task is to find the y parameters for the network shown in figure. Y parameters for the network shown in figure. This question is asked in the exam May 2017 for 4 marks in the Ahilyabai Punyashlok Ahilya Devi Holkar Solapur University Solapur examination. Okay, now if you check, our task is to find the y parameters. As in my previous video, I told that the preferable law to find the y parameters is the Kirchhoff's current law, right? Kirchhoff's current law. Now, here, if we consider this as a reference node, that is a 0 volt here. So here it is a 0 volt, here it is a 0 volt, here it is a 0 volt. Here it is 0 volt means here it is V2, right? Here it is V1, potential here it is V1. Now, can we say that this terminal and this terminal, this forms a single node? Yes, this forms a single node, and here it is we are having the one node, right? So if here it is V2, definitely here it is a V2 potential will appear. Okay, so further, yes, we can write here reference node potential is a 0 volt. So here potential is V1 volt, here potential is V2 volt, here it is also potential V2 volt. Or we can represent this branch, that is a 3 into I2, as like this. We can represent this branch like this also, right? Next, so consider the branch currents I1 and I2, they have already given, right? Consider current here is I3, I4, I5, right? I5. Next, apply KCL at V1, right? KCL at V1. If we apply KCL at V1, yes, it is like I1 is equal to I3 plus I4. I1 is equal to I3 plus I4. Next, can we replace I3 in terms of voltage and resistor? Yes, with the help of Ohm's law. It is V1 minus 0 divided by 1 is equal to I3. That is a V1 by 1. What is I4? V1 minus V2 by 2. It is a V1 minus V2 by 2. So further, can we simplify it as? Yes. So I1 is equal to 3 by 2 into V1 minus 1 by 2 into V2, right? So y parameter characteristic equations are I1 is equal to y11 V1 plus y12 V2. So it is like y11 is 3 by 2 mho and y12 is minus 1 by 2, right? It is minus 1 by 2 into V2. Okay, so y12 is minus 1 by 2. Next, can we apply KCL at V2? Yes, KCL equation at V2, it is I2 is equal to 3I2 plus I5 coming, right? So I2 plus I4 is equal to 3I2 plus I5, right? I2 plus I4 is equal to 3I2 plus I5. Next, can we replace or can we write it as I4 minus I5? I have shifted this I5 at this side. It is 3I2 minus I2, right? So 3I2 minus I2 is 2I2 is equal to I4 minus I5, right? Now our task is to write the expression for I2 in terms of V1 and V2. So we need to replace I4, I5 in terms of voltages. I4 is V1 minus V2 by 2. I5 is V2 by 2, right? So we can write it as V1 minus V2 by 2. I4 is replaced with V1 minus V2 by 2. I5 with V2 by 2, right? So further we can write it as I2 is equal to this like this. And next, further simplifying, I2 is equal to 1 by 4 v1 minus 1 by 2 into v2. So it is like I2 is equal to y21 v1 plus y22 v2. So what is y21? Y21 is 1 by 4. Y22 is minus 1 by 2, right? Minus 1 by 2. So comparing equation 1 and 2 with the characteristic equation of y parameters, right? Characteristic equations of y parameters. So we can write y11 is 3 by 2 more y12 minus 1 by 2, 1 by 4 and minus 1 by 2, right? So next, so this is one example for finding the y parameter, right? This question has been asked for the 4 marks, right? Now let us discuss one more example. Solapur University examination question, right? Determine the y parameters for the 2-port network. Y parameters for the 2-port network. Okay, now in this circuit we are having, yes, consider this as a reference node. Okay, so it is a 0 volt potential here, right? Here it is a 0 volt potential, right? If here it is 0, here it is V2, right? Here it is V2 means here it is V1. Okay, so we have written or we have redrawn this network as, I have just simply represented this branch as it is connected like this, right? So same circuit. So next, consider potential volt. Here it is 0 volt. Okay, same here it is also 0 volt. Okay, next, so if 0 means here it is V1, here it is V1, here it is V2. Okay, next, one more thing, consider the branch currents as I1, I2 given, I3 here, I4 here, right? Here it is 2V2 current already given. This current I have taken it as a I5. Next, one more important thing is for finding the expression for I4, right? So here current direction I4 is shown as left to right. So this should be plus, this should be minus. Okay, at this side the potential is V1. At the minus side, what is the potential? Be careful, this is a voltage source of value 2V1, right? At the positive plate of the 2V1 voltage source, the potential is V2, right? So whatever the potential at the negative plate, what is the function of the voltage source? To create a potential difference of 2V1, right, between positive plate and the negative plate potential, right? So it is like V2 minus this potential is equal to 2V1. So can we write this potential V2 minus 2V1. So here it is V1, here it is V2 minus 2V1 I have written, right? Next, apply KCL at V1 and KCL at V2. What is the KCL at V1? Yes, incoming currents are I1 and 2V2. So it is I1 plus 2V2 is equal to I3 plus I4, right? I1 plus 2V2 is equal to I3 plus I4. Yes, I1 plus 2V2 is equal to I3 plus I4. Next, I1 is equal to, this can be written as I3 plus I4 minus 2V2. Our task is to write the expression for I1 in terms of V1, V2, right? So we need to replace I3, I4 in terms of voltages, right? What is the expression for I3? Expression for I3, yes, it is V1 minus 0 by 1, that is a V1. I3 is equal to V1. What is the expression for I4? V1 minus in bracket V2 minus 2V1. So it is like V1 minus V2 plus 2V1. So it is like 3V1 minus V2 I4. So it is I3 is V1 by 1, I4 is V1 minus in bracket V2 minus 2V1 by 1 minus 2V2, right? So I1 is equal to, after rearranging the terms, we will be getting this equation. So we are having I1 is equal to Y11 V1 plus Y12 V2, right? So what is the Y11? Y11 is equal to 4 mho. Y12 minus 3 mho, right? Minus 3 mho, right? Next, apply KCL at V2 or second loop, second node, KCL at V2, right? So what is the KCL equation? I2 plus I4. Current here is I4 means current here it is also I4. So I2 plus I4 is equal to I5. We know I4 is V1 minus in bracket V2 minus 2V1. And what is I5? V2 minus 0 divided by 2. Okay. So we can write it as KCL at 2. So it is I2 plus I5 is I2 plus I4 is equal to I5, right? So I2 is equal to I5 minus I4. I5 is V2 by 2, and what is I4? Yes, V1 minus in bracket V2 minus 2V1 by 1. After rearranging, we can write like this. So I2 is minus 3V1 plus 3 by 2 V2. So I2 is Y21 V1 plus Y22 V2, right? So what is Y21? Minus 3, and Y22 3 by 2, right? So are you getting the point? So compare 1 and 2 with the characteristic equation, and you will be getting Y11, Y12, Y21 and Y22, right? So these are the some examples which have been asked in the Solapur University examination for finding the y parameters, right? Finding the y for 4 marks, right? So in my next video we will discuss about parameters. So thanks for listening.